Hi, this is Harish here. Welcome to DB2 LUW Tips and Tricks video tutorial part 170. In this tutorial, I'm going to talk about how a large log buffer helps in faster rollbacks. The scripts that I'm using, the data files that I'm using are available for free download at db2lewacademy.blogspot.com. Please subscribe to the YouTube channel youtube.com/db2lewacademy. So this is the problem scenario. So we want to understand how a large log buffer helps with faster rollbacks. So the goal here is to demonstrate how this large log buffer helps with a scenario where we can reproduce it with the scripts. And also, like, the current committed queries will also benefit because of this large log buffer. Like when a transaction runs, the transaction log records are generated, and as the transaction log records are generated and put in the buffer, it is also getting written into the disk. So the log buffer is more like a memory area where the transaction log records will be there for a particular transaction, and whenever some application requires that particular log record, so it could be because of a rollback or it could be the current committed queries, so which is looking for that current committed value from the transaction log record. So for that, it has to read the transaction log record from the disk log file. So instead, it will obviously, if you have the buffer, that will be the first place to look for, and it's easy to find in memory than in the transaction log disk files. So, and obviously you need to allocate more memory to hold more log records. So that's like trivial. And the demo scenario that I want to show is, and before that, like, it's not going to be like, I don't know how much significantly it is going to improve your performance or something, but definitely having a good, like a decent large buffer helps. So I would say that, because I don't have much real-time hands-on, but yes, conceptually it makes sense. And the demo scenario is like, I cannot really show how it reads the log record from the active log location, so I have to come up with some kind of a workaround. So the workaround here is have a database with archival logging enabled and configure it with infinite logging. Okay, so you can run a huge transaction that will generate a lot of log records and don't commit the transaction. And if these transactions, the log records, are in the log buffer memory area, which you can adjust using the log buff size parameter, and when you initiate a rollback, the concept is we don't need to retrieve the log records from the archive location by means of retrieval of the log file. So that will not happen if you have sufficiently big log buffer. So what you can do is like use the log buff size parameter before and after scenarios. So run a huge transaction with less log buff size and see, like, you can observe, like, if you run a huge transaction and roll back, and you will see that the retrieval of log records are happening, which means for that rollback it requires those log records which it cannot find in the log buffer memory area. So it is going to access the disk, and it is not available in the active log location because you have configured infinite log location. So it has to retrieve from the archival location and play back and do the rollback. So that is a kind of workaround, but that way we can understand when there is a requirement for that particular log record or for that particular transaction details, it is going to hit the hard disk, right? So I can show that. In after scenario, you can just increase the log buffer size and see that it is actually not retrieving any log records from the archive location. So that is the idea of that. Okay, and let's go and look at the demo. So like I have the demo. So this is the location: db2admin downloads, db2admin sample node 00 logstream c003 150.log. So this is the current archive location, and this is the current active location for the particular database that I am talking about, which is like sample database. And let me just, I'm already connected to the sample database, and let's look at log second. It is -1, which means like infinite logging is configured, and the log buffer is 2048, which is minimal, right? Like 8 MB or something, right? Okay, so now what I'm going to do is just run this SQL file. Like I need to just create a transaction, okay, and I'll just run that, okay, copy that and just paste that. So this z.sql just contains some transaction, and I'm committing the first one, and after that here you can see I'm running like so many times, right? So it generates a lot of log files without any commit on that, okay. So let it run for a while, and we'll observe what happens in the archive log location. So okay, so you see 150, 151, like one after the other the log files will be archived, so you can see that. And in the log stream here, 151, 152, 153, 154, like it's still up to 163 is available. It will take a while. So it's going to take a while. This transaction is going to take a while. This transaction is going to take a while. And let's see in archival what happens. So 150, 151, 152, 153, 159. And log stream you see 151, 154, 151, 159, 160, 161, 162, 163. Okay, I should see some like the thing that I'm expecting is there should be a gap of log files, then only we can retrieve, right? So I'm just looking for that gap. So let's look at that. Okay, see 150, 151, 152, 150, it's continuous, okay, up to 164, okay. And here 152, 3, 4, 5, 6, 7, 8, 9, 60, 61, 62, 64, 65. Let's see. Okay, so that transaction is not enough, I guess. So I'm just going to run it one more time, okay. So 152, 53, 54, 55, 56, 57, 58, 59, 60. I should break this continuity. That's what I'm trying to do. Okay. Okay, let me do it one more time without commit. So 152, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73. Okay, so 152, 3, 4, 5, 6, 7, 8, 9. Okay, after 159 you can see there is a gap appearing. 3 log files of gap is there, right? So let me run this one more time. So we'll just run as much as possible. So the scenario is to repeat until you get 20 log files missing in the active location. So like this is the one I'm saying. So 159. So after that 160, 161, 162, 163, 164. So 5 log files I'm missing as of now. Like you can see, like I'm missing 5 log files, like 159 to 167. So 8 log files are missing. So I can run pretty much like that. So few more. Now it is actually 10 log files are missing. So I just want to miss 20 log files, so that when I roll back, it will roll back those transactions. It has to retrieve those missing log files from the archive location. So that is the idea. Okay, so let's see what happens here. 159 to 171, so which is like close to 10 log files. Okay, So I think I cannot give this. So what I'll do, I'll copy from here 3 times, copy that, just paste it. Okay, give it in one go. So you should be able to now miss a lot of log files. So you can see 158, 159. So after that it started missing the log files. So 150, 160 to 174, which is like more than 15 log files it is missing. And everything is going in the archive location. So if you look at here, so all the log files are getting collected in the archive location, and I should be able to roll back without any issues. So but the only thing is like 159, you can see 178. So that is the missing log file I'm talking about. So these log files will be retrieved. So once you roll back, these log files will be retrieved. That is the concept. So let's go here. Okay, this is huge. Okay. (160 to 83). So 23 log files, 24 log files. I think I may be overshot a little bit. Okay, so done. So I'm gonna say db to roll back. Okay, so let's look at the script for that. Yeah, repeat, then roll back. And so before I roll back, so I'm gonna say here, so 160 to 85. So roughly about 25 log files is missing, and those will be retrieved actually. So when I issue the rollback, those will be retrieved. So when I say rollback here, so you should be able to see that it is kind of retrieving those log files. Okay, there you go. Log stream, see, it's retrieving all the log files, 180, 183, 184, 181, 180. So it's going in a reverse way. So 179, 178. So it's kind of moving the, it's not moving, it's copying the log files from the archive location to the active location, and it is trying to roll back the transaction, right? So you can see the rollback is still happening. So for the rollback to complete, it has to retrieve up to the 150 or something, 151 or something. So let's see how much it retrieves. Okay. So it has retrieved up to 165. So this is the retrieval. So if I'm able to hold those 20 log records, right? 20 files of log records. Here it is 25. So roughly 100 MB speaking, right? So roughly 100 MB of, so I need like 100 MB of log buffer. So I'll configure 200 MB of log buffer. Okay. So you can see in the log stream, like all the things have been played back, and the rollback should have been complete. So this is the idea of log retrieval, and this log retrieval happens because it is not able to find the log records in the log buffer, because it's not holding that much, right? So I'm going to update this as 50,000, and I'm going to connect reset, and I'm going to connect to sample again. Okay, done. Okay, and let's kind of prune the history file so that we are left with some disk space. So I just don't want to mess up my disk space. So 2025 12, and it should be like 2025 December 22 19. So it should be like 1925. Let me say 1925. So let's look at the timestamp for this log file. If I look at the archive location, so this is 198. So what will be the timestamp for it? Okay, it doesn't say that way. So open in terminal here and say ls-lh. Okay, so yeah, 25. Okay, so I'll just exit. So I'm going to give the prune history command and run that. So that is just for the sake of this. Yeah, so I have cleared the archive log location so that I have some disk space available, and I'm going to run the same kind of thing. Okay, the same kind of thing. So same scenario. So commit and run it 4 times. Okay, copy that, paste that, hit enter, hit enter. There you go, and observe what happens. So it should start archiving the log files, and you can see here 199, 200, 201, like all those things are there. Let's look at this. Now it has archived 199. So I think it is going to take a while. 199, 200, 201. So there is continuity. So I just want to create a break of 20 or 25 log files, and it shouldn't. The point is, this time, like if I look at this log stream folder, it should not retrieve any file from the archive location because the log buffer is huge, 200 MB, and it should be able to hold those log records. So it should not retrieve. That's otherwise all this demo is, it's just waste of time. So it shouldn't retrieve. So I've done it couple of times. So like I prepared this scenario myself. So I just repeatedly run it couple of times, and hopefully it should work. Okay. Because with memory allocation, you never know, but we'll see. Okay. So 199, okay, here. So 199, 200, 201, 202, 203, 206, 207, 208, 209, 210, 211, 212. So it's still running with the continuity. So okay, did it complete? Okay, it has completed. So 200, 201, 202, 203, 6, 7, 8, 9, 10, 11, 12, 13. So I did not hit, oh, okay, I should not commit the transaction. Good, that I saw that. Okay. So I'm gonna paste this and hit enter. Then go back to the log stream folder. 200, 201, 203, 204, 205, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I should see a gap in the log files. I'm just waiting for that to occur. 200, 201, 202, 3, 4, 5, 6. Because maybe my log primary is maybe huge, I guess. That's why it takes a while. Maybe I should give like 10 as my log primary. So let's check how much is our log primary like that. So we can open another terminal and just say db2 get db cfg for sample pipe grep-i log primary. Yeah, 13. So that's okay. So 13 is the most standard one, only default. I think it's default. Okay, let's go here. 200, 200, 201, 202, 6, 7. Okay, I think after 207 I'm starting to miss the log files, right? Yeah, 207. So 4 log files are missing now. So you can see here. Yep. So 5 log files are missing. So 207 to 212. So 208, 209, 210, 211, 212. So I'm missing now 5 log files. Yep. I'm missing 6 log files. Okay. I'm missing 7 log files. Okay, So I'll just paste it again. So here. I will paste that and hit enter and go here. So from 207 I'm missing more log files. 208, 9, 10, 11, 12, 13, 14. So I'm missing like 7 log files. Now it is 8 log files I'm missing. Let me miss like about 20 log files. Okay, so that's really huge. It's going to take time. It's not a very powerful machine, so it's taking its time. So 220, so again 13, roughly 14 log files we are missing. So I'm just going to run, keep an eye on this. Okay, 222 minus 15 log files. There is a gap of 15 log files. So it should retrieve 15 log files of data when I do the rollback. So I mean, it should not. If it is able to persist all the transactions, then hopefully it should not. So 18 log files, I think now we have reached about 18 log files. And then all I have to do is just run a rollback. So we have reached 20 log files and we are breaching the 20 log file limit. I guess 20 log file is about 80 MB because 20 log file of transaction is like 80 MB. Yeah, so then I am going to start my rollback, but before the rollback, so let's look at 207, 220. So roughly about 19 log files are there. Okay, so roughly about 19 log files of transactions are missing in the active log location and they are in the archive log location, and I'm going to hit a rollback. And this rollback, so if I come here log stream, it shouldn't retrieve any log files and it should roll back without retrieving. So you can see here, if I say view reload, no retrieval, the rollback is still happening, and I'm going here view. I mean, you previously saw that the retrieval was happening, and now there is no retrieval happening from the archive location to the active location into the log stream subfolder, and no retrieval happening absolutely. So this is the power of the log buffer, because it's the rollback is still going on. So we'll just keep our fingers crossed. But by this time it should have retrieved some log files, I guess. Okay. The rollback completed without a single log file retrieval, because it is able to find all the log records in the log buffer, which is 200 MB, which is huge, right? So that is the scenario that I wanted to show you, and how this rollback, whether it is a faster or not, like I'm not going to say like it's going to be significantly giving you a good, maybe I should have timed it. Like I should have said like time db2 rollback, like that is, I should have done that, but I don't think so. It's giving you more of a performance benefit. Like it's not big in terms of the performance benefit, but in terms of accessing the sheer number of log records from a disk rather than from the memory, should count, like at least theoretically. Okay, so that's the idea. Okay, that's it in this video tutorial. Hope you enjoyed. See you in the next video tutorial. Until then, bye.